Hi everyone, this screencast will be a quick refresher on factorial notation and combinations. So let's begin with factorials. If I have n factorial, n is a positive integer, 1, 2, 3, 4, etc., then it would be the number n itself multiplied by the integer which is 1 smaller, n take 1, multiplied by the next integer which is 1 smaller, n take 2, all the way until we get to 3 by 2 by 1. Now, let's have a couple of examples. What if we go 4 factorial? This would be 4 by 3 by 2 by 1. Now, we can calculate this pretty quickly. 4 times 3 is 12, times 2 is 24, times 1 is still 24. Isn't that nice? Now, mathematicians, we're pretty lazy as a bunch. If there's a shorter way to write something, we'll take it. So if I look at that 4 by 3 by 2 by 1, and I note for myself, if I just focus here on 3 by 2 by 1, wouldn't that be the same as 3 factorial? Couldn't I save myself the effort of writing all of that if I simply put 4 times 3 factorial? And of course 3 factorial means 3 by 2 by 1. It's exactly the same. It's a much more compact way to write. Now it also leads to some interesting results. Now I'm going to go 3 factorial next. I want to know what 3 factorial is. Well, before I write what's in the middle, let's skip to the end. Let's use the previous working. If I divide by 4, won't I be left with 3 factorial? And that means I'd have to divide this by 4. So 24 divided by 4 is 6. That's also the same as 3 factorial. And of course 3 factorial is 3 by 2 factorial. Now I want to know what 2 factorial is. Well, divide through by 3. 2 factorial is 6 divided by 3. That's 2. But in this more compact notation, I suppose, we would go it's 2 multiplied by 1 factorial. Interesting. Let's keep going. 1 factorial. Well, if I divide 2 across both sides of this previous equation, 2 divided by 2 gives me 1. And of course, 1 factorial is 1 multiplied by, well, don't I have to use the smaller one? 0 factorial. That's interesting. 1 multiplied by something equals 1. What's the only possible answer then that would make this true? 1 multiplied by 1 equals 1. 0 factorial equals 1. It's the only possibility for making this thing true. Or you can just divide through by the 1s, couldn't I? The green 1 divided by the green 1 is 1. 0 factorial equals 1. That's amazing. And that's actually true. It's a very important result. A lot of people mistakenly think that 0 factorial equals 0. If you come across one of these poor misguided souls, please set them straight. Otherwise they'll forever be making a terrible mistake. 0 factorial equals 1. Now that we've got that under our belt, let's do some combinations. So N, C, R. Sometimes also written as N, R with a pair of brackets. I don't like that notation because it reminds me of a vector, and sometimes people put a vinculum between, and it is definitely not a fraction. Do not put a vinculum between them. So I much prefer NCR notation. It's very, very clear that it is a combination we're talking about. Now, what is the formula for this thing? It is n factorial over n subtract r factorial multiplied by r factorial. Lovely. But what does it all mean? Well, what it means is we are selecting this many objects, select r objects from a group containing n objects. And we're looking at how many different ways we could select. So obviously n must be greater than or equal to R. You could not select, say, 5 objects from a group of only 2 objects. That would just be nonsense. So it's sensible to say select 5 objects from a group of 10 objects, say. That makes sense. Now let's have a bit of an example to get a header. Let's go 5, like I said, C3. This means we want to try and choose 3 objects from a group of 5 objects. So let's list this. It's 5 factorial over n take r is 5 take 3. That's 2 factorial multiplied by r factorial. That's 3 factorial. This is multiplied. Interesting. Do we really have to multiply this all the way out? No, we don't. Now, I'll leave the denominator as 2 factorial by 3 factorial, but the numerator I will change. Now, remember last time I went 5 and then I put 4 factorial, but I don't have a 4 factorial to cancel with, do I? So what if I make the 4 factorial into 4 times 3 factorial? Hooray! Now I can cancel the 3 factorial. Brilliant. Well, I shouldn't have really called myself brilliant. I didn't invent that. I was taught that by my teacher. So thank you to Mr. Strutton from high school who taught me that. So 5 times 4, of course, is 20. As we know, 2 factorial is 2 times 1, or 2, which means there are 10 different ways of choosing 3 objects from a group of 5 objects. 10 different ways to do it. Excuse me. We could write them out if we wanted to. It'd be a bit tedious, much easier to calculate like this. And that's how we use factorial notation to simplify our combination type work. That's about enough for now, I think. So, oh, sorry, one last thing. It's not enough for now. I forgot that I was going to show you how to do this on your Casio graphing calculator. So you need to be in the Run Matrix app, first of all. Oh, I've got some things there from last time, so I'll just clear all of that stuff. Now, I do not see a combinations key. I don't even see a factorial key. So what I'll do is I'll hit the options button. No, it doesn't look good. Move across. Probability is where this topic lives. There's the factorial key. So let's just try 4 factorial, and we should see that that equals 24, like we thought. Let's try 0 factorial, and yes, it equals 1, just like we thought. So the people who made the Casio calculators knew their maths. Now we've got NCR. Now what did we do? We did 5C3, didn't we? Equals 10, just like we thought. Of course, we could always do it 5 factorial over 5 take 3 brackets factorial by 3 factorial. We could write it just the way we did on our notes. And of course, we still get the answer 10, don't we? So, now that's enough for this video. Thanks for watching, and I'll see you next time.